Okay, so again, this is lab number 2 for the course Modeling and Analysis of Manufacturing Systems. And I'm going to be showing also some of the things that we covered last time, just to keep you informed about these concepts and terminology that is very important. Again, I'm going to be referring to these names over and over again, so that's why I like you to keep an eye on them. So the way we're going to do our lecture today is we're going to go over the slides, and then we're going to work on an example as we did last time. And then you're going to have a lab that is going to be due on our next lecture. Okay, so I posted that lab already. So let's go over the instructions. So again, remember to save your document once you start working on that example and also on your lab exercise. It's very important that you keep saving your model, because there's a high chance that if you don't save it, you're going to lose it, and then you're going to have to start over again. So always make sure that you follow the instructions to save your model. So now let's get started with the Arena modules. So we already covered the resources module, how to use it to represent a machine or any resource that we need to use in a company or industry. We talk about how we need to use a resource module in the elements, and also to define our experimental frame. And then how to represent a resource using the seize, delay, and release blocks. So those are the 3 blocks that are listed here. And we already know what's the difference between them and what is the purpose of each one of them. Now, in terms of the new modules, we're going to start working today with the block called assign. And this assign talks about the assignment of values to user defined entity values. What this means is now we want to provide certain characteristics to each one of our entities. For example, if we want to collect information in terms of the cycle time of a part, how much time does it take for the part to get completed? We need to assign an attribute to that part to record the time that the part arrives to the system, and also when you're done with that part, you want to record the time of leaving of that entity, and the difference is going to give you the cycle time. Okay? So that's one example. Also, you might need to differentiate between the parts. You have 2 different products, 3 different products, and you want to represent and make sure that you are processing part 1 on machine number 1, part 2 on machine number 2. So an assign block can also help you assign that type of attribute to that entity to represent that, oh, okay, so this part is blue and this part is red. They might need to, through different processes or different flow within the company. So in order to make sure that I'm processing the right part, I'm going to assign an attribute, and I'm going to be referring to that attribute when I'm deciding where to send the part. So that's the idea. The assign block will allow you to keep or to define an attribute to the entities, and those attributes are going to be used in your simulation model. But as we did for the other blocks, in order to assign an attribute, you also need to define an attribute element block in your experimental frame. So, for example, if you're going to be collecting information or estimating information about the arrival time, you need to define an attribute here, arrival time, and then you can ask or use that attribute here in the block. Okay, so again, you define first, and then you use them in the model. Any questions? Okay, so that's why I'm showing them their link, because you need to use both of them together. So in order to assign an attribute, once you have defined your element block, the name of the attribute, you can double click on the block, and you can assign different types of attributes by just adding Just clicking this add button and naming the attribute name. The attribute name will go together with some type of equation that is going to allow you to collect information that you need. Okay, I'm going to show you that with the example. In terms of the suggested naming scheme, I would recommend you to use a lowercase first word, no spaces, and then first upper letters for the next word. So you can give them everything, all the name together. For example, if you're naming it start time, you use lowercase for start and then uppercase for time, and you keep the two words together. The reason I'm saying this is because Arena is very case sensitive. So if you don't remember where you put the space or how you name that thing using spaces, it will get very complicated when you start naming or asking for those values in your model. So keeping everything together with no spaces usually help to avoid those case-sensitive errors. There's another block that we're going to use today, and this one is used to make decisions. So if you're familiar with flow charts, it's basically the same idea. You're going to have some type of question that you want to answer, and depending on the number of answers that you're going to have, you're going to have a certain number of branches. So if you have only two decisions, then you're going to have two branches. And this could be any type of logic, like, for example, we have a certain amount in terms of percentage. If 50% will go to one machine and the other half will go to the other machine, you can define that equation in the branch block. Something that is very important here is that we always need to define this maximum number of branches and make that equal to 1. That would force the entity to take only one branch of the decision block. Okay, if you don't put that, the Arena model can duplicate the entity. So we want to avoid that. Okay, so we want the entity just to go through one of the branches in our model. Okay, so those are the two blocks that we are going to be using today, the newer blocks, again in combination with the blocks that we learned on the previous lab. But today I'm also going to be focusing on how to collect some of the statistics from the simulation model. Okay, so in terms of statistics, we already know how to use the counter block to count the number of entities that were processed in the model. So this is the first block that we have to collect statistics from our model. But the new modules include some tallies and 10 average statistics, 10 persistent statistics, and I'm going to explain what's the difference between the two. The tally is data for which there's a natural first, second, third observation. So basically, this is like putting something inside a map. So if you're collecting information about the cycle time, let's say this is your plot, and every part that is completed will go outside, like when it is done. So what we are going to be doing in this tally block is you're going to start putting those entities that are completed into that map. Saying that, for example, the cycle time of the first part was 2 minutes. The cycle time of the second part was 5 minutes. And the tally block will keep adding that information. Let's say you have 100 entities. The 100 entity has a 7-minute cycle time. And that's the only thing that you will do. You will keep all the information in that map. So you're basically collecting all the data points related to that statistic into that map. The idea is once you're done running your model, you can take all those data points and, for example, compute the average. Or you can compute the standard deviation or the confidence interval. But using the information that's inside of that. Okay, and that's what the tally is. Okay. So there's a difference between a tally. So Since the value of them are tallied when they are observed, are going to call them tally statistics. For example, the cycle time. And we're going to define this variable TAVG. That is going to be used to look at the average of um, this statistic across replications. And you remember when it was mentioned, you can run experiments for the one time that we did last time, run it for 1 day, and you got a result. But most of the time, we want to run these experiments multiple times, like 10 times, 20 times, so we can have some type of randomness in the experiments that we are running. So we know when you run the experiment once, you're going to get some results. On the second time, you're going to get some different results because the randomness in the system is different. You're using a different random number replicator. Well, you're using the same random number generator, but you're using a different seed. So that will make the statistics and the results make different. So now you're going to run this from 1 to 10. And at the end, you want to know, okay, if I took the average across replications, what the average is going to be. And that's what are we going to be doing using this TAV. Okay, so for now, this is just mentioned. I'm going to show you how that works in the model. And we also have some time average statistics. These ones are different because this one cannot be computed in this way. For example, if you're looking at the width or the working process is something that is changing continuously. Like it's not discretized. You will have every, I don't know, in the continuous time frame, the width can change any second. Like every time you have a part arriving and another one departing, that number will change. So that's what we call a time persistent statistic. Okay? And we have a different way to compute statistics for those type of measurements. And those are what we call time average statistics. And those are weighted average of the width weighted by the proportion of time of the run that the system has that particular width. Okay, so we're going to be tracking this measurement by also taking into consideration the time frame for the simulation model. And for those type of statistics, we're going to use a different variable. This is called the DAVG to obtain the average across applications of time average statistics. Okay, so for now, let's think about cycle time as being a valued statistic, and we're going to get that using a tally log. But the time persistent statistics are going to be collected using a variable, and I'm going to show you how to do that. But this one is a different type of statistic because this one will be changing continuously throughout the replication of the simulation. Okay, so that's the major two difference between these two. Any questions? And I think this is going to make more sense once we start applying it to the simulation model. But for now, we talk about tally and tally statistics. So for those, we also have a block that we can use to collect that information. So, so the Tallies element defines all the information needed for tally blocks in the Simon model. And this tally block is using, is also used, they're used together. These blocks tallies the complete set of internal cost and times attributes for the entity. So for example, the cycle time, the cost, and so on. And you'll see that we're going to be using this now variable from Arena to collect the cycle time. So for now, talking about three different Arena defined. So Arena defined variables. We have TAVG, we have DAVG, and we have TINA. Okay, so these three are defined by the software, and they're going to be used for specific things in our simulation. Okay, so I want to keep that list there because we're going to refer back to it later today. Okay, another thing that is important is the use of sets. So today we're going to start looking at process that have more than one type of product. And for collecting information about different type of product, let's say I want to know the cycle time for product 1, and also I want to know the cycle time for product 2. So we need a way to split or to differentiate those two types of entities in order to collect statistics. So a way to do that is to use a set. So here it defines a group that may be referred by a common name. It has a unique index. Okay, so this can be used in combination with Tallies Elements. So for example, if I want to get the cycle time and I have three different type of parts, I can define a cycle time for all of them together, a cycle time for each type of product. But in order to use this information, I need to define a set that is going to put them, those three together. And that's what I'm doing here. So I define a set that is called cycle time by part, and I put these three as elements of that set. Now when I go and collect the statistics, if I want to know the cycle time per part, then I can call this set in my statistic block and get the information. And we are also going to use that today in our example. And the DStats element is also used to collect some statistics from the system, and this is used to obtain the time persistence statistics in the discrete system. So for example, as I mentioned, the working process. Another one could be the utilization of the machine. So in order to get the information of that, those statistics in the model, you can use this stat block and use this NR variable. And this one is associated with the resource utilization. So T now is for getting the time, the current time of simulation. ENEG is for the average across replications. For time persistence. Statistics. And TNEG is for the average across replications. Or Tallies statistics. If you want to keep those in a list, that will be good too. I have a sheet with all the variables that are defined by Arena, and I'm going to bring that next time. And it has all the variables and the use for those variables in the model. But for now, those are the most important ones. So again, in order to get the statistics across multiple replications, we need to perform an additional step. And basically, what we're going to do is we're going to use the output blocks to ask Arena to generate those statistics for us. So, for example, this DAPG, PAPG, MC is going to be also, this one is associated with the counters. And we are going to define all those statistics in order to get the information across replications. Okay, so basically what the output element is going to do is going to generate a summary report of all the performance across replications in your model. And I'm going to show you that too. Okay, so let's look at the example that we're going to work with today. This is, again, a manufacturing process. We have different type of parts arriving to the manufacturing process. So we have A and B. Okay, so they're different, and they are arriving using an exponential distribution. This is the arrival time, 4.4 minutes, and then 60% of the parts are A, and those are going to be processed by drill number 1. And 40% of the parts are B, and those are processed by drill number 2. Okay? We have the processing time for each one of these machines given in terms of a triangular distribution, and that is defined here and here. And using this information, we want to collect, or we want to answer these questions. So we're going to run the experiment 10 times. Okay? And the answer is going to be stated in terms of the average of the 10 experiments. Okay? So the answer to these questions, the first one, what is the average cycle time for all the parts? So that takes into account all the parts together. Then what is the average cycle time for only type A? Third question is in terms of part B. The fourth question is the average utilization of machine number 1. And finally, what is the average number of parts completed? Okay, so that's the information that I want to collect from the system in terms of this example. Any questions? Okay, so let's get started. So you can open the Arena software in your computer if you haven't done it yet. And again, the first thing is to work with the experimental frame. So I'm going to be defining all the things that I need for building my simulation model. So I need these two template, the blocks and the elements. And I'm going to start with the elements. Okay, so we have two different type of machines, right? So we know that we're going to have a queue in front of each one of them. So I'm going to start by defining these queues. So I'm going to use the queues element block. Is it too small? Okay, so I'm going to start by defining my experimental frame. Let me make a note here. So this is my experimental frame. And I'm going to have a queue for each one of the machines. So I'm going to add two names here. I'm going to make it very simple. I'm going to name the first one Q1 and the second one Q2. So Q1 and then add another one Q2 and then click OK. So now you should have two names for the two queues in your queues element block. We also have two machines, right? So I'm going to define the resource elements to name those machines. You can give it any name that you want. You can call it machine 1. You can call it drill 1. I'm just gonna use machine 1 and then machine 2. Okay, so I have my resources now. Okay, so as I mentioned, today we're gonna collect some information from our system. And as you saw, some of the questions were referring to the part type, and we have two different types of parts. And also, we need to collect some information about the cycle time. So these entities will have two attributes assigned to them. One of them associated with the type of part, and the other one associated with the time that they arrive to the system. Okay, so I'm gonna list or name those two attributes, and for that I need the attribute set. So the first one, I'm gonna name it part type. And the only thing that I have to do right now is to define the name. So this is part type. And I'm using the notation that I mentioned. So there's two T's here, one lowercase and one uppercase. Yes, sir. Yes. I need to go and get a. Okay, so we define the attribute in terms of part type. Now, I want to define another attribute, and this one is going to be associated for the collection of the arrival time. Okay, so for that one, I'm going to use a different name. Arrival time. And then we also click OK. So I have two attributes, two resources, and two queues so far. What else? We are going to be using some counters, right? We need to count if I'm not the number of parts completed, which is the last question. So let me define the counters. We only need one. So let me add that. Number parts. Or number of parts. What else do we need? Based on our previous knowledge. So I think for now I can use these four to build a model, and then I'm going to add some more elements later to collect the statistics. Okay, so let's start by defining this, the model with these elements, and then we're going to get back to the experimental frame to collect the statistics that we need. Okay, so the information that we have is we're going to get some parts arriving to the system. So for that, we need a create block. So now I'm going to go to the blocks panel or template panel, and I'm going to start building my model. So I need a create block to generate the entities arrivals. And before I continue, let me be a good professor and say this, giving you the instructions, and I'm not doing the same. So let me save this. This is model 2. Okay, so I'm going to go a little bit faster now because we understand how to use the create plot. So the arrivals are given in terms of the inter-arrival times are given in terms of the exponential distribution. So you can use the build expression to do that. So you right click and get the exponential distribution, and the mean is 4.4. Any questions? No? Okay. So I have my first block, and after I create the entity, I want to assign the attributes to that entity. Okay. So as we discussed, we're going to use the assign block for that, which is going to use the attributes that we define in the attributes element block. Okay, so I'm going to find that assign block from the blocks, and I'm going to connect that to the create block. The first attribute that I'm going to define is, once I create the entity, what is the time in which that entity arrives to the process. Okay, so the first attribute is the arrival time. Okay, so I'm going to add, I'm going to double click on that assign block, and I'm going to add an attribute. So now you need to type the name of that attribute here, but it has to match the name that you put into the attributes element block. So I'm referring to the arrival time, so I'm going to type the same name, arrival time. Okay? And now I have to provide a value for that. So as I mentioned, there's a variable in Arena that gives you the time, the current time of the simulation. So that's the variable that I want to type here. Okay, so the value is going to be t now. Okay, so that value, basically what it's going to do is going to look at the clock of the simulation model, say it's 10 o'clock, it's going to assign that 10 o'clock to that attribute, and that's going to get assigned to the end. Okay, so that's for the arrival time. Now I want to define the second attribute, which is the part type. We know that 60% of the parts are going to be part 1 or part A, and 40% or the rest are going to be part B. So in order to assign that attribute, I can use a distribution that is called the discrete distribution. And I think I mentioned that one in the previous lab. So basically what we're going to do for the value, we're going to define that discrete distribution, and we're going to say 0.6 of the entities are going to be part A. We cannot use letters in this function, so I'm going to, instead of using A, I'm going to name it 1. And then the rest, which is the complement of this one, is 0.6 plus 0.4, 1, are going to be part 2. So these are the probabilities that are cumulative, and these are the names. Okay. If there were, and this is because we have 60% A and 40%. In this case, we're naming it 1. What would happen if you have, for example, 3 types? And the first one is 30%, the second one is 40%, and the third one is 30%. And what to define this in? Yes. So you will do, correct. So you do discrete, 0.31, 0.72, and 1. That's correct. Okay. So that's the idea. And I think you're going to have to do that for 3 parts on the lab exercise. Okay. So keep that in mind. So now we're going to define the second attribute, which is the part type. So I'm going to use the same assign block, and I'm going to type the name of this part type, and the value dimension is going to be this function here. So it's 0.6112. Any questions? No? Okay. So those are my 2 attributes. Now I can send these parts to the machines, but I now need to split them because part A will go to machine 1, part B will go to machine 2. So in that case, I'm going to be using this decision block, which is the branch block, to split those entities. So if you go click the branch block from the blocks modules, double click on that one. The maximum number of branches is 1, so that's correct. Now I'm going to use the branch types module here. So I'm going to add a condition for splitting these entities. So in this case, you have 2 options. You can use the attribute, and in this case, you have to use the attribute because we are already defining the type of entity with the attribute. So we're going to use that attribute to define the condition to split the entity. So the condition that I'm going to use is the attribute name part type. So I'm going to type here part type again. And if you're familiar with programming, at least for the logical operators for programming, the double equal means that you're going to look for that is the same number. Okay, so basically what I'm saying is if part type is equal to 1, then I'm going to send that part through one of the branches. Okay, so if you click OK, and then OK again, you have the condition under the branch block. And then we can create another branch by saying if that condition is not satisfied, then you're going to send the rest through the else branch, which doesn't require a condition. And that's what we're going to do. So I'm choosing that else, then OK. And we're going to have 2 branches, one for the condition, and then the rest for part type number 2, which is basically the same as saying send the rest through the else branch. So I now can close this, and you'll see that you're going to have these 2 branches here, these little triangles here. So the first one is for the else, the second one is for the if. Okay, so we have that condition defined. Now we can model the machines. And to model the machines, we need the QC's delay release blocks. So we basically need to replicate that logic for both machines. So I'm going to start with the Q, C's, delay, and then release. Okay, so far I haven't put any information on this logic, right? So one thing that I can do to save some time is to copy this logic and then paste it, so I have the same logic ready for the second machine. So I'm going to select this, I'm going to copy and then paste, and I have the same logic, and I can connect that one to the second branch. Okay, so nothing is inside this block. I just copy the logic so I can start editing the information for each one of the machines. And I connected one, part type 1 to the second branch, so this one will represent machine number 2, which is machine number 1, and the top one is machine number 2. Okay? So, let's start with machine 1, which is the one at the bottom. So I'm going to define a queue for that one. And double click on that queue ID. You'll see that the names are already available, so you can choose Q1 and then click OK. Then you're going to see machine 1. And then click OK. And we are going to delay this according to the information here. Machine number 1 uses this triangular distribution. So I'm going to copy that and I'm going to use it here. So it's a triangular 3.2, 4.2, 5.2. And what is next? You release the machine once you are done with that part. So I'm going to go to the release block and I'm going to release machine number 1. Please let me know if you have questions about it. Because we're going to repeat the same logic now for the second machine. So let's go and define the queue. So the queue ID for machine number 2 is Q2. Then we're going to see machine number 2. And the delay is going to be defined as we have here in the PowerPoint. So the delay is a triangular 3, 4, 5. So you can type that or you can copy the information to save some time. So the duration is in terms of that distribution. Triangular 3, 4, 5. And then we're going to release machine number 2. Okay, so we have our logic defined for the machines. Any questions? Okay, so the only thing that we need to do now is to collect the information that we need from the system. And that will be the last step on building this example. And so we can first define the counter because we only need to count all the parts. Okay, so and we already have the counter element defined. So I'm going to find a count block from the blocks basic process. I'm going to put it at the end because I'm going to connect both of the machines to this count block. Okay, and I will double click on that one and find the name of the counter that I defined in my elements. So what that's going to do is to count all the parts that cross or that are processed by both machines. Okay, so we also need to get the information in terms of the attributes, right? So we want to collect information about the cycle time. So for that we need to define a tally, as we discussed this earlier this morning. And we haven't defined those tallies yet, right, in our experimental frame. So now we need to go back to the experimental frame and find the tallies element. To collect the information about the cycle time. And remember what we're going to do is this. Every time the part crosses that block, we're going to put that information into the tally. Okay, so I'm going to define the cycle time for both parts together, and then the cycle time for each part independently. Okay, so the tallies are going to be the following. I'm going to call this CT for cycle time. That CT is just for, let's make it clear. So cycle time. Cycle time all. Okay, so this is for all the parts. So that's the name of the tally. Then I'm going to have a second cycle time for part 1. So I'm going to call this one T cycle time P1. And then a third one, which is the cycle time for part 2. Cycle time part 2. And those are the 3 Tallies elements that I need for this model. 1 for both of them together, and 2 for each one of them independently. And then I click OK. So those are my tallies. Now, as I mentioned, this information is what I need, but in order to split the information for these 2 types of entities, I need to define a logic that will do that for me. And in order to do that, I'm going to use a set. Okay, so a set will allow me to split the information to get the information for each one of the type of parts in terms of the cycle time. So I'm going to define a set in my elements that is going to have 2 elements. So this is the set. It's also part of the elements module. So if you double click there, I'm going to add a set here. I'm going to call it cycle time or CP by type. Cycle time by type. And the elements of this set are cycle time part 1 and cycle time part 2. Which are the names that I define in the tally. Okay, they have to match those things. So those members are coming from And you will see how this works in a second. The other thing that is important, you cannot put them on the same line. Okay, because the software is not going to identify them as two. You have to put them on separate lines. Okay, so that set is defined. And then I can close everything. So I have the tallies and the sets. Okay. So I think I can define the rest of the logic using this. So I'm going to add a tally block. Actually, I'm going to add two tally blocks just to make sure that you see the difference. So if I go to the blocks module, I will define two tallies, one for all the parts and one for the set. But you can actually use the same one for applying the both logics. So the first one is going to be defining the cycle time for all the parts, not by type, the cycle time for all the parts. So the tally ID is going to be cycle time all, and the value, now I need you to understand what I'm going to do. So the value now is defined as an expression. So basically, we know that we have an attribute for each part that recorded the arrival time. So we know what is the arrival time for each one of the parts. Now I need to use that attribute to compute the total cycle time of that part. So what you're going to do is you're going to use this variable again, the t now. You're going to ask the simulation what is the current time, and I'm going to subtract the attribute of my part. And that's going to give me the cycle time of the part. Okay, so that expression is going to be t now minus the, what's the name of the attribute, arrival time? Yes, arrival time. Okay, so this is going to be for all the parts that cross that block. Okay, just want to make sure that I'm using the right, yes, arrival time. Okay. Now I need to define the second tally, and this is going to be for the set. Okay. So this is going to be defined as follows. I'm going to put the name of the set. Okay, make sure that I have the right name. Okay, so that is going to be CT by type. That's the name of the set. What is the attribute that defines the part type? Part type, right? So I'm going to use that attribute to split the parts. So basically, you put the name of the set, you open the parentheses, and you put the name of that attribute, part type. So in order for the tally to record a value now, it's going to look at these expressions, and it's going to see, oh, if this is 1, I'm going to put it in the back for 1. If this is 2, I'm going to put it in the back for 2. Okay, so it's going to be splitting those observations based on that part time. And then the value is going to be the same expression, now minus the arrival time. Any questions? Yes, thank you. Yes, it's the W. Any other questions? Okay. And finally, in order to complete this logic, I just need to dispose my entity. So I can go to the blocks module and find the dispose block. I don't know if you can see the whole logic there. So let me save this. And let me check if everything is good. Check model. So my model is saying that it doesn't have any errors. So again, you can go to check if you have any errors so far, go to run and check model. And let me know if you see anything wrong. Any errors? Nope. Good. Yes, sir. Okay, let me pause the video. I think we didn't specify a time duration for this for this simulation, right? Nothing stated here. So we need to run 10 replications, that's given. So let's run this for 10 hours. Okay, so we can run this, go to setup. We're gonna run this for 10 replications. I'm gonna run it for 10 hours. And I'm going to use my base time unit for minutes, because everything is given in terms of minutes, the processing times and the arrival times. I'm gonna hit apply. I also want to define the report that I want to use. So go to reports and shows the last one, or choose the last one, Simon. And then also I want you to go to the project parameters and uncheck these three. I don't want to have anything checked there, because now we're going to define the statistics that we want to collect from the model. We don't want Arena to give us all the information. Okay, so if you did that, now hit apply and then OK. And now we can run this. Okay, so these are the results that I'm getting so far. I have the cycle times and I have the number of parts processed. What I want you to notice from this report is that now, since you are running 10 experiments, I'm going to ask you 10 different reports. So this is replication 2 of 10. Now I have replication 3, 4, all up to 10 reports. So I have a report for each one of the experiments. Okay, is that clear? What we want to do is, I want to use all these experiments and get a report that takes into account all the replications. And that is not given by this yet. Okay, so we have to generate that one. That will give us information about the average across replications, the variance, and the confidence interval. Okay, so that's what we want. So for that, we need to define some extra elements. First, I want to make sure that I'm collecting all the information that I need. Okay, so I'm getting the cycle time, I'm getting the number of parts completed, but I'm not getting the utilization yet. Okay, so I want to define that statistic in my model. And in order to define that statistic, I need to use a new element block that is called DStats. DStat. Okay, so I'm going to go find that element block here, and I'm gonna grab that DStat block. DStats, and I'm going to define an expression that will give me the utilization of machine number one. Okay, so as I wrote here, there's a variable defined by Marina that gives you the utilization. So I'm going to use NR machine one. Because I want the utilization for the first machine. And then click OK, and OK again. And that should look like that. Now if I run my I need to do one more thing. So go back to that DStat and click Edit. I need to provide a name for this. Okay, and that's very important. So I'm gonna call this machine 1U, meaning that is utilization. Okay, so make sure that you put a name here under the assignment expression, because our index is going to be referring to that generated report. Okay. So if I go now and I run this again, now I should see the utilization of machine one. And it looks like it's reporting it as 0. Okay, I will check on that, make sure that, find out what's going on. It's supposed to work and give you the machine utilization, but maybe they changed the variable, so I need to double check. But one more thing that I want to do before we dismiss our lecture today is to get that summary report. Okay, as I was mentioning, I want to know a report, get me a report of all the statistics across replications. Okay, I think you're going to need to use the utilization for the machines in your exercise. So maybe what you can do is, for now, keep using this resource statistic collection to get that information. I mean, if you run this now with that, it should give you the machine one utilization. So it looks like the machine is not being used. Okay, let's continue with the the last block, and then I'll go get back and find out what's going on. So in order to get that report, we need to use an element block that is called output. So let's get that output elements block is here. And I'm going to double click on that, and I'm going to start defining some of the average that I want to collect from all replications. Okay, so the first expression is going to be related to tallies, and those are, again, I'm going to be using the DAVG to get that information. So this is DAVG cycle time. This is the cycle time for all the parts. Okay, so DAVG cycle time, and then click OK. I'm going to add another one. This is DAVG for cycle time part 1. And then I'm going to add the same expression for cycle time for part 2. I'm going to do NC for the average across replications for the counters. So NC for number of parts. And then finally, I need to define one for the utilization, and I'm going to be using this name to get the average for the utilization. So machine 1 U, remember you're going to use that name. So the utilization is a time persistence statistic, so that's why I'm going to use a DAVG instead of a TAVG. So machine 1 U. Okay, and then click OK. So now if you run your model, have an error. Okay, sorry. Thank you. This one. Okay. Thank you. Let's see, check your model. So if you run this now, if you go to the end of the report, now you have a output report that takes into account all replication on your experiment. The good thing about this is it's going to give you the, actually let me uncheck the utilizations. Let me uncheck that utilization. Okay, so this is the report. So you have an average across replications for the counter, an average across replications for the cycle time, and I'm going to find out what's going on with this one, if I have time. Because it looks like it is working because they're getting some output for R type 1. So I don't see why that machine is not being used. Let's see. So I have machine 1. Yeah, it has to be something here. I'm going to check on my own and find out because the entities are flowing, because we're getting some of them processed in machine number 1. Still, it doesn't make sense if you have all the parts going to that machine, why it's not having any utilization record. So I'm going to go back and check my model and find out what's going on within the inside the logic. But this is all you need to work on your exercise, which is already available on track. So I'm going to send you an email once I find out what's going on with the utilization of that machine. Any questions? Nope. Okay, so